Hello, everyone. Thanks for joining our webinar today. I'm Ryan Evans I'm the communication specialist with the Center for Agricultural Profitability here at the University of Nebraska-Lincoln. And if this is your first time joining us, we're really glad you're here. This is part of our regular webinar series that happens most Thursdays during the noon central hour. And you can, of course, find out more about our webinar series, including an archive of all of our past recordings, and register for upcoming sessions on our website at cap.unl.edu. And we're really excited today to be talking about behind-the-meter solar electric systems for the farm especially. And today we'll be covering the general design elements of behind-the-meter on-farm solar, walking through production, value of electricity, and interconnection policies, as well as how these all impact economic return. On-farm solar is marketed across the state as an option to lower electricity costs, yet the interconnection policies do vary across the state based on the thresholds with respect to the net metering law. So these policies, as well as electricity prices and system costs, can lead to varied economic returns across the state, but we are in good hands today to find out much more about it. As presenting, we are pleased to welcome John Hay, who is an extension educator with Nebraska Extension, working out of the Biological Systems Engineering Department here at the University of Nebraska-Lincoln. If you have questions as we go today, please do type those in the Q&A box, and we'll work to answer those by the end of the hour. So John, thanks for joining us, and I'll turn it over to you.
Thank you, Ryan. Good to be here. I'm going to try to do my best to represent this topic and the complexity of it and try to make at least some sense so that if you are interested or in this market for a solar array, you have some direction to go with respect to looking at the economics of it or finding an installer and things like that. The first thing we really want to do is make sure that we're on the same page with respect to terminology. When we think about solar, there are really two scales, and there's lots of different sizes, but we'll really think about it as two different scales of either behind the meter distributed solar, which systems that exist literally on the customer side of the meter. And so those can be various physical sizes, but they are on the customer side of the meter. And then there's the utility scale, the really big ones, and a lot of times the farmer is interacting with those by leasing land for that development or something like that. That's a really different topic and kind of exists and has its own set of rules and challenges and laws and so we need to be clear that we're talking about these distributed small systems today. There's lots of reasons people want these systems, and I just want to kind of reiterate how important people's goals and desires are, because somebody might say, well, John, you know, I don't know if the economics is good enough, and maybe we ought to be telling people that the economics aren't good enough on these. And I said, well, I think we ought to tell people what the economics are and help them calculate them, and then they can determine for themselves whether that is good enough. And so an example of that is we have a farm that maybe has some green energy goals and some desires to generate their own green energy. A person with those goals might have a different threshold for what is a good economic return on this system versus somebody that is purely looking at having this for a reduction in their costs. Also, their need or desire to utilize that tax credit is going to be different among different farms. Some farms do some direct marketing from the farm and want to direct market some green products. So having a solar array there could be part of that marketing, and that marketing has value. And so again, there's different reasons to put these in, and that influences people's decisions. The initial system cost these systems is high, and so that's a negative on the investment of this. There is operation and maintenance, and if you move, you may not regain that investment. Now, that doesn't typically a worry for a farm as much, but when we talk to residential owners, they say, well, are you going to live in that house for 15 years to pay that back? Well, no, I might move, you know, so that may not be recouped. There's also ways to invest in solar outside of owning it. There are some community solar projects. There are pros and cons to those as well. And that's where you would buy in to a larger scale project that might be near your community. You can claim the green energy. You don't have to have a place to install it. You can sell it that back if you need to, or you move. You don't have the O&M, operation and maintenance risk, but you also may not be able to access the tax credit. Some you can, some you can't. It is not at your location. So if you have that desire for marketing, you don't have that physical thing there to show that you, for people to see. So just some reasons where motivations and goals make a big difference on how you view the economics. I just wanted to point this out, that solar is a form of green energy, but one of the things that I hear sometimes in social media is that, well, it took a lot of energy to build this system and to install it. That's true. And we ought to not ignore that. So when we look at how much energy it took, when we account for all the emissions of building and installing and everything else, and we divide that out across the kilowatt hours across a period of time, these are the emissions for different sources of energy based on some of the research studies. And so we can see that solar, in this case, utility scale solar, but small scale solar will be slightly higher, but not a lot different, is 6 to 14 grams of carbon equivalent emissions per kilowatt hour generated. Those aren't zero. You know, solar energy, some people might say it's zero emissions. Well, if we draw a boundary around the solar panel itself, no emissions are coming off. But the emissions that were given off in the construction and installation are what we're talking about in this 6 to 10. But compare that to the fossil energy resources. The worst fossil energy resource from emissions is coal. The best is combined cycle natural gas. And when you look at Nebraska's generation mix, this is both coal, natural gas, nuclear, hydro, wind, and a small amount of solar. Nebraska's mix in 2017 was 628 grams of carbon emissions per kilowatt hour. So we need to recognize that it's a mix. It probably actually has gone down some since then because of our some increase in our wind resources and solar resources since then, but not a lot different. Different states are going to be different. I installed it, one at my home in 2017. I just wanted to represent that to at least give you a picture of what one looks like, as well as maybe represent a little bit of my experience. I installed this myself at that time, and it has run without any operation and maintenance since 2017. Maybe someday I'll have some. I expect I will, but up to this point, it has operated as expected. But here's my production across that time. You can see that it does better in the summertime and less in the winter. That's because the hours of sunlight are greater in the summertime. Hours of sunlight are less in the winter. I'd like to point out that February has been quite variable. And that is because the snow cover on some Februaries has caused me a loss of production, particularly in 2019 and 2021. That snow cover really hurt me. But during the other months, it's much more uniform. May is variable, I think, because sometimes the May is very rainy. We get a lot of cloudy days. Other months in May, we haven't got very many cloudy days. So some variability, but really quite uniform in the mean across all those years. Let's look a little bit about the steps in the process. And I think these can be informative as you consider this for your operation or not. I think that you all might be in this number one region of studying your electric bills and efficiency and trying to decide if this is something that I might be interested in. The solar homework is thinking about, why do I want this or not want it? What are my goals for it if I choose to pursue solar? You're going to get quotes and talk to multiple installers. It is important to get more than one quote because it will really inform you about what types of installers are out there and what are the costs, and really help you decide, try to get the best one. You want to contact your utility before signing any contract for installation. This is important because your utility there are different policies out there that I'm going to represent, and you do not want to be surprised by that policy. And so if that policy ends up making the economics not good, you want to know that, or if there's some other problem, you need to know that and not be surprised. I'm not going to go through all the steps of the blue. That's where the installer does the installation and a lot of the steps in that installation. At which time you get that finished, you're going to have a utility agreement that gets signed so that you can get your new multi-directional, bidirectional meter, turn it on, have that utility do their site inspection. And then finally, I want to point out at the end, this online monitoring is critically important. You want to be able to pull that up on the internet or pull that up on your phone and see how it's doing for multiple reasons. But number one, isn't it fun to show off and be able to say, look what I'm generating right now? That's great fun. But more importantly, I can then monitor that to make sure that if it is functioning properly, do I need operation and maintenance? Do I need to get it fixed if it goes down? I can do that if I'm monitoring it. If I don't monitor it, I might not know for a long time that something is wrong, because you might only have a certain component that went out, but the rest is still functioning. So that monitoring allows for that. The other really, really important purpose of monitoring, online monitoring, is that some of the manufacturers require that to be connected to the internet to initiate the warranty. So if you don't hook it to the internet, it's not effectively under warranty until it is. And so you need to get that warranty initiated for that. And a lot of times that warranty comes, you actually end up calling the company and saying, you know, look, this component is down. They will look at it online and maybe even accept the warranty application right there by what they can see from that online data. We're here for economics. So let's get into that. This is a rudimentary cash flow for solar. So I have the gross system cost, the cost of what it is to install that. I have the federal tax credit that everyone is available to everyone. And I say everyone, that's a little bit weird, because it used to be that was available to everyone that paid taxes and had a tax burden. Now with the new Inflation Reduction Act, you can actually access, and in lieu of taxes, tax credit payment. And so really this is now effective that everyone can get this 30%. That gives us a net system cost, at which time then we have to pay that off with the savings that system provides, which is the production times the value of the electricity. So let's do a really rudimentary economic analysis this is my residential example. I'll get into the farm example in a moment, but the residential example is informative as well. I have a 5 kW solar array. If that were cost $3 per watt to install, so 5 kW is 5,000 watts, $3 a watt is a kind of a ballpark figure for what systems cost today. That's $15,000 gross system cost. I get a federal tax credit of 30%. The net system cost $10,500. The production of that system, I'm estimating at 7,100 kilowatt hours a year. And what is the value of that savings? Is basically I'm offsetting what I would pay for electricity. So that's in Nebraska, between 5 and 10 cents per kilowatt hour, based on winter and summer and other things. So I'm made a kind of a medium value at $575 of savings per year. The payback is 15.56 years. Now, that's really rudimentary because I'm missing lots and lots of details, but it's a good place to start. So let's add some details. I have the gross system cost. I have the federal tax credit. If I'm a business, I can use depreciation and get some additional tax savings. There are other grants and incentives that may be available, and that's one of the reasons for this webinar today, is that there are some grants that are very exciting, that are accessible to farmers and rural businesses. I get the net system cost, but then I can't forget that I have other details like the operation and maintenance of that system, and maybe some added cost of insurance. I have to take into account the time value of money. And so we're going to work our way through this cash flow one piece at a time, try to give you some background that will help you think through this and maybe do some calculations or call somebody like me to help with some calculations. So here's this one, this residential example again, where I added in some of those details by running it through a model that helps me look at the value of that, of those and the cost of those other pieces. And then the payback increased by about almost a year to 16.2 years when I add those other costs in. So let's start with gross system cost. The gross system cost, so everybody says, what does one of these systems cost? Well, it's much easier to look at it per watt because it depends on how big the system is. A person that puts in a 10 kW system is going to have a different cost than somebody puts in a 20 kW system. These were the costs as of 2018, where residential is about $2.70 a watt, commercial is about $1.83. Unfortunately, inflation and logistical, the logistics of getting equipment and some of that has increased that. So in 2023, I'm going to estimate those at just a little bit higher. I'm seeing residential systems closer to $3 a watt, so I put about $3.20, and commercial systems at about $2.50 a watt. Now, this is where you get multiple quotes, and don't expect that number to land exactly on that, but I think this is a good ballpark figure to figure out what these systems cost today in Nebraska. The federal tax credit. The federal tax credit is fairly simple to access in the sense that you spend money to install the system, then you fill out the tax paperwork on your on your taxes at that time. For residential, it simply says how much did you spend, multiply that times 30%. As it gets into these commercial systems, which a farm system would be considered maybe a very small commercial system, it works out very similarly, but there may be an additional form or two to fill out, but it equates to the 30% tax credit. There are ways to get a production tax credit where you get paid the tax credit per kilowatt hour, but that tends to not work out as cost effectively to use that for smaller systems. It works out better for systems that are more like a megawatt or larger. So systems that are under a megawatt tend to use the investment tax credit of 30% rather than the production tax credit in that way. Though commercial systems can access some additional value potentially. So this says that the base tax credit is 6%, but if the developer uses prevailing wages and other things, it increases to 30%. So I think that 30% is going to be reasonably easy to access, but there are some additional bonuses that could happen. Domestically made materials is one. If you can prove that those materials for the solar array are domestically made, an additional 10% tax credit is available. So that's one of the reasons that a number of solar manufacturers are starting to either grow their manufacturing businesses in the United States or move some of their manufacturing to the United States to try to take advantage of some demand because of this additional tax credit. Depreciation, I'm not going to harp on depreciation. Essentially, businesses get to use depreciation to depreciate their assets quickly and get some tax benefits for that. And you can actually claim depreciation on 85% of the federal tax credit, I believe. So you actually get a little bit you can actually claim some of the value of that tax credit. So that's good as well. But so I'm not going to harp on that. There is bonus depreciation. It used to be 100%. I think it's now declined to 80%, but we can claim a lot of that in the early years, the year 1, year 2 of those installations. Let's move over to other grants and incentives because that's where some of the excitement is right now. Particularly the Rural Energy for America Program grant. This is some updates from that grant. I'm just going to go highlight some different pieces. A lot of times this is called the REAP grant. It stands for Rural Energy for America program, and it is a program to give grants for energy efficiency and for renewable energy. And so there are multiple ways to get that. In the Inflation Reduction Act, which passed in late last year, and they just wrote the rules for finally now, they have added some additional funding to that grant. And so that's going to be really good, because it makes more money available for people that want to use that for energy efficiency or renewable energy projects. This is not a guaranteed grant. You do have to apply and get accepted. So you don't plan on this being guaranteed money. You apply and put your best application forward and see if you can get it. This is where it's also very exciting, is that it used to be 25% of eligible project costs. Now it is 50% of eligible project costs. So now you can imagine, if I have a gross system cost and I take 30% federal tax credit off, but then I also take 50% cost share on that, that net cost goes way down, and thus the economics can start looking really good. They are accepting applications on a quarterly basis now. So, they always wonder when they're available, but you can now look. They're due in April, July, October, January, and then April, July 2024. In Nebraska, this is who you'd want to contact to discuss this. It's contact your local USDA rural development contact. So Bill Shepard is kind of the statewide person. And out of the Norfolk office, Bill Shepard and Dan Yankee, and then Jolene Jones in Kearney, and Marla Marks in Scotts Bluff. Otherwise, try to find, go to the website for USDA Rural Development, type in Nebraska, and you'll find those contacts. All right, now we're going to get into solar production and what is the how much electricity are you generating? And so how much you generate depends on where you're at, but also the orientation of the solar panels. And so we are in the northern hemisphere, so we're going to face solar panels south typically. And so if you can face a solar panel south, you're going to maximize production. So what this chart is looking at what is the percent of the maximum when we face a solar panel in any direction other than south, as well as any tilt angle, the angle that it is tilted to the south. And so we can see that maximum production is happening when we face that solar array due south at a tilt angle between about 34 and 48 degrees. This is in Lincoln, Nebraska. As we move across the state, these numbers change only slightly. So as we move north, the optimum would just move a little bit higher. As we move south in the state towards the state line, we would just be a little bit lower, but pretty much the same in the same general vicinity across the whole state. But where this is important is people will ask me, well, I have a really good roof to put this on a building, but it faces east or west. And as we face these east or west, it's important to understand that we're going to lose potential production. If we face it either east or west, we're losing about 20% of what we would have got if we had faced it south. That's not necessarily a deal breaker, but we need to include that in our analysis that it's going to generate 20% less. We can't assume it's going to generate the same as if it was facing south. So we need to take those things into account. Ground mount systems are systems that usually we can optimize. Face them due south, tilt them at the optimum angle, and have that optimum production annually. And so what I have here in the middle, though, is where it kind of rounded to 100% and then where it rounded to 98% or better. And so having that be at the optimum tilt angle isn't necessarily critically important, because even if we're just off optimum, here we have maybe let's say you have a 412 pitch on a building. 412 pitch is about 20 degrees. It sits in about that 96% range. So we're losing a few percent, but it didn't hurt us a lot. And so it's not probably worth it to try to adjust that tilt angle of that roof. So just kind of an example of production. You can estimate that production with certain calculations, but there's also some good websites out there. One is called PV Watts. It's a renewable energy lab product from the federal government, and they do a good job of estimating production at an individual location, assuming there's no shade. So shade is an X factor. If assuming there's no shade, those estimates are really good. How big of a system should you put in? There's lots of different philosophies here on what size it should be, but if you want, in all cases, your solar array should produce less than you use annually, equal to or less than you use annually. And that is because it is behind the meter. The utility does not want you to be a generator, and you don't want the extra paperwork of becoming a generator. You want to be saying you're trying to offset your own load. So your system should be sized to produce less than you use annually. You might have it be close to 100% if you have green energy goals. If you have you're more concerned about economics as well as green energy, but then you size that smaller, usually smaller than 75% of your annual use or load. That's where better economics play in, and you'll understand that more in a moment when I talk about some of the policies and how those policies impact the value of each kilowatt hour generated. You can size it based on available space. For example, a roof may limit how big it can be. Same way with a ground mount, you could do that. You could size it based on a budget in that case, where you say, I have this much money to spend. I didn't add this one, but there's also the policy, the state policies that might dictate, which if you can access net metering in your utility, that limits you to 25 kW. And so you could maximize, just max out that 25 kW. But most farms are going to put in systems that are 25 kW or smaller because of that rule, that net metering law. So now let's get into the depths of our complexity in the value of that electricity. The first thing to look at from a value standpoint of electricity is go to your electric bill or your electric rate schedule and understand what you pay for electricity. That will help you to determine, if I generate solar, what might it be worth, because it's offsetting what I'm buying from the grid. In this case, I just ran an example farm rate schedule that's very simple. I say a number of farms are on rate schedules that are similar to this. There are quite a few that are more complex as well. In this case, I have some version of a monthly charge that I have to pay no matter what. In this case, I do not have a demand charge, but more and more farms and residences are having some type of demand charge. And then my energy is costing me between 6 cents and 10 cents per kilowatt hour. In this case, 6.7 cents in the wintertime and 7.9 to 10 cents in the summertime. And so when we do an economic analysis and we say that all of our electricity is worth one number, let's say it's 10 cents, that's clearly going to overestimate the value of that electricity, because solar generated in the wintertime can do no better than offset 6.7 cents in this particular rate schedule. So it's important to understand what our rate schedule is and what we're paying for our electricity. It's a great place to start. Then we want to work through what policy is available to us in our particular utility. Statewide, there is a net metering law, but that net metering law has a threshold that once a certain number of systems have gone in, or a certain capacity of systems have gone in, that utility no longer has to provide that net metering law to the next customers. So Most of Nebraska still has net metering available to them, but there's a number of utilities that don't. That's why I'm going to represent the other two policy options that have been adopted in the state of Nebraska and are the most common. So net metering, the customer gets credit for most, if not all, of the instantaneous electricity flow that flows to the grid. I'm going to explain this in a chart next, but I want to get some terminology first. Net billing, the customer gets wholesale credit for all instantaneous electricity that flows to the grid. And a buy all, sell all is kind of what it is that all the electricity is sold at a rate usually lower than retail, and all of it is purchased back at retail from the grid. When we apply those different policies to the same system, we get different returns. In this case, net metering 16.2 years, net billing 19.6, and buy all, sell all over 25 years. So if somebody says, well, how good a deal are these in Nebraska? Well, one of the questions is where are you? What utility are you on, and what are the policies of that utility? Because that's going to help us understand what the possible return on investment can be. Let's review these quickly. I'm going to draw on my screen here and try to represent these three different policies so we can help understand them. In all of the different scenarios, we have three flows of electricity. We have the grid generating electricity and being used in the home. So think about that at night. At night, I'm just buying electricity from the grid. The sun comes up, the solar begins to generate, and that electricity is used instantaneously by the load, reducing how much is being purchased from the grid or coming from the grid. As maybe I leave for work and the solar is generating really well and the electricity flows out to the grid. All three of those flows are taking place all at the same time, potentially. I mean, they're all just happening. It's all instantaneous kind of happening. But the meter can measure these two top flows in either direction. So we're going to call this A and this B. In net metering, at the end of the billing period, the electric utility is simply going to subtract A minus B. That is the net in net metering. And so if A was 500 and B was 400, A minus B is 100. And you owe the utility for 100 kilowatt hours. Thus, all of what the solar generated, because the solar might have also generated 200 down here that got used instantaneously, all 600 that the solar generated was essentially valued at the retail rate for electricity. And thus, that has the highest value possible to the customer in this sense. Now, the state law clearly, though, defines what happens when there's a negative. So let's say that A was 400 and B was 450. So A minus B in this case is negative 50. In that scenario, the utility owes you for 50 kilowatt hours because you sent that to them in excess, but they're only going to pay you call it a wholesale cost. The term is avoided cost, but we'll use the term wholesale value for that electricity. So they're going to give you less for that excess, net excess generation. So that is net metering in a nutshell. But what's important to understand is that in this scenario, most of the electricity generated by the solar is credited or valued at retail rate. So a lot of times that's why this particular policy yields the best economics return for the customer. Net billing. Net billing is a little bit funny because there is no net in net billing, but that's okay. We'll still call it net billing because that's what the industry calls it. Let's draw those three flows of electricity again. We'll label them the same, A and B. And in a net billing scenario, at the end of the billing period, they'll say, how much A did you generate? And they'll multiply that times your cost of electricity. We'll call that 10 cents just to make a round number. And that's how much you pay to the utility. And then they give you a credit, B times the avoided cost rate. Let's call that 4 cents. And they give you a credit for all of B. All of the excess generation is credited at the wholesale. That's net billing. And a number of utilities in Nebraska that have reached the threshold for net metering have then adopted a net billing policy for additional customers. This flow of C down here, it is still valued at the retail because it is a reduction in how much A was purchased. So that C was used instantaneously. It's still valued at full retail because it was avoided purchasing of A. Buy all, sell all is a little more complex, and I'm going to do this in two ways. I'm going to do it in the way that helps our brains understand it, and then I'm going to show how it actually works. But first of all, we're just going to simply draw a line and say all of the electricity that is used is purchased. Imagine that it's all purchased from the grid. And then imagine that everything that the solar generates is sold to the grid. And so all of it is sold to the grid at 4 cents. All of it is bought from the grid at 10 cents. That's a buy all, sell all. But that's not the way it functions. And the reason I point this out is this system is still installed behind the customer's meter. So they can't meter it in this way. And so this is how it's generally metered. So I'm going to go through another little version of this. We're going to install a secondary meter right here. We're going to call this the solar meter. And then we're going to have our 3 flows of electricity, because those 3 flows are still happening. A, B, C. In this case, A times 10 cents is what you pay. And then B times 4 cents is what you're credited. And then they take the solar meter and they subtract B, and that gives us C. And then that C is purchased from you at 4 cents times 4 cents, and then sold back to you at 10 cents. 10 cents, 10 cents, 4 cents, 10 cents. A little complex, but that's what's happening, is that this C is credited to you at 4 cents, like you sold it to them on the grid, but then because you used it in your home, then you buy it back from them at 10 cents. And so that's how the buy all, sell all is kind of functioning at the moment. There are a couple of utilities that have adopted versions of this buy all, sell all as their policy. And you can imagine that when everything you generate is worth the wholesale rate of 4 cents versus, let's just use our example of 10 cents, this is usually the policy that yields the lowest economic return for the customer. I'm not trying to say anything about these policies other than how they impact the economic analysis. Let's talk about operation and maintenance for a moment and the time value of money, and then we'll wrap up with an example again. Operation maintenance, some of the things included: any costs of monitoring, keeping up your internet and other things, replacement of equipment under warranty. Yes, it's under warranty, but you may end up hiring somebody to come out and do the install of a piece of equipment. Broken panels due to accidents, rocks, bullets, kids, stupidity. I'm listing all of the reasons I've seen solar panels get broken. We could also say, I didn't list hail, which is something that can break panels. They're pretty tough. They don't get broken by them a lot, but then those are under your insurance. And so I don't necessarily consider that so much an operation and maintenance cost, even though because hopefully that's paid by the insurance. We have to replace equipment that fails after the warranty. And so there's some costs there. And so these are some of the costs I build into an economic analysis to make sure that we are more confident that the numbers that come out are good. There may be an additional cost for insurance. There may not be. Some insurance carriers have added additional costs, some don't. So it'd be important to ask your insurance carrier if the system had an additional policy rider or something like that. A good analysis is going to consider the time value of money, and that money in the future is worth less than money today. And so we're discounting future cash flows so that we can do a good economic analysis. The other thing to think about is that the value of my electricity sales will be higher in the future. Electricity costs tend to go up. Now, the utilities in Nebraska have done a really good job of maintaining those costs for a number of years. But what will happen is they'll maintain for 5 or 6 or 10 years, and then it does jump. So it does go up over time, just in little jumps across time. So I tend to use a more flat increase to represent those jumps over time. The cost of capital and loans and things like that we need to include. So as we put this whole thing together, we can then begin to run models to look at this. And let's just run an example. I'm going to run this without the USDA REAP grant. This is my first example. So our gross system cost for a 25 kW system, I went to $2.8 a watt, so $70,000 gross cost. Federal tax credit, 30%, minus $21,000. We're not going to get the REAP grant. I'll show that in the next slide. The net system cost, actually, this 27 should be in it, so this isn't quite right, but I went to the bottom to get better numbers. We do have $14,000 depreciation. We do have production at about 34,000 kilowatt hours a year, equating savings of about $2,500. So our simple payback is 12.5 years under that. When we add the REAP grant in, we get a simple payback of 4.3 years. And so that's really, really where this REAP grant can get exciting, because if we can get that, the paybacks come down to a very short number of years. So that economic return, we know this thing's likely going to have a good economic return for us. This is the economics that are more exciting. 12.5 years in the previous isn't necessarily bad. It's just not as exciting as 4.3 years payback. We're going to go to questions in about a minute or two, but remember that the reason that that economic analysis in solar can be sometimes complicated is a couple of fold. Number one is we have to apply the policy correctly. And to do that, we need to understand whether the electricity went to the grid or was used by the house. And so we need to look at that on an hourly basis and typically model our load and our generation on an hourly basis. And that's where the models can really help us do that, to really look at. So here's just an example of a farm that I ran, and in which case there are 2 months where the solar generated more than the load. And we need to be able to take into account, based on the policy, what is the value of those kilowatt hours. So in those models will model on an hourly basis whether the electricity went onto the grid, got used instantaneously by the load, or however, where was that direction, and then what were the appropriate values for that electricity. And then we can then get some level of data. So this is just the run that where I got the 4.3 years. And so here's a simple payback of 4.3 years, the discounted payback with our time value of money included. We have some other details like how many kilowatt hours were generated and things like that. And if we do a good job with our discount rate, we can then create a net present value to determine whether that was a good investment or not. So these models can do some really good things and are more detailed than the basic economic analysis that you could do on the back of an envelope. Though I don't mind back of the envelope calculations, they're just a place to start, not necessarily where you want to finish. Most systems are not going to have batteries. And the reason is that batteries are very expensive. Batteries add a lot of maintenance. And what is our purpose for that battery, which is backup? Do we need that? And are there other lower cost ways to have backup? So in a farm system, farms may desire some type of backup generation because they need it to pump water for their animals or something like that. I would then try to question, is a battery backup the most effective, cost-effective way to do that? Or is some type of a generator, gas or propane or diesel, the way to go? And so most systems do not have batteries, but they are an option. If you're interested in looking at the economics of that, it does raise the price of the system quite a lot. That's going to be the end. Here's my contact information. I have quite a bit of this information. I have some videos and publications on how to do an economic analysis. You can find those at my website, bioenergy.unl.edu. With that, Ryan, I will open it up for questions.
Well, thanks so much, John. That was great. We have a couple of questions about the recording of this, and we will post the recording in the webinar archive section on our website at cap.unl.edu, cap.unl.edu. That should be up by tomorrow afternoon, I suspect. And John, we'll just dive in here. Going back to the start of your presentation, there was a question when you were talking about the maybe the environmental impact of installing solar in terms of carbon emissions. In your comparison, you said that the numbers included the installation of panels, but did that also include manufacture and shipping?
Yes, on those numbers, those particular studies did try to include everything. Again, that's why there's a range, because, you know, where were they shipped from, but it does give a range. So yeah, those attempted to include everything. Yes.
Perfect. And we'll remind people that if you have questions, you can type those into the Q&A panel in Zoom. And some of these may have been answered during the presentation, but I think it's worthwhile to touch on them again, if we don't mind, John. So one participant said that their electric association does not support renewables and is at the caps for net metering. Can a solar installation without net metering pay for itself by completely severing the relationship with the utility?
Yeah, this is a really good question, Alan, and it's really kind of complicated. It is. I'm going to say that my short answer is no. It probably is not cost effective, but the part of that problem is to completely sever with the electric grid. You need to be your own, you know, microgrid or mini grid, and thus you've got to have your own storage and your own utility. And the cost of those systems are very, very high, and so that really hurts the economics. The reality, though, is that all utilities have to allow some level of interconnection with renewables, though the policies that they put in place are different, like we represented. And with that USDA REAP grant, if you can get it, the economics can still sometimes work out with, let's say, even a buy all, sell all arrangement, if that USDA REAP grant is received. Without the REAP grant, it's many times it's not economical to do that in some of those different policy scenarios. But I would really say it's going to be very difficult, if not unwanted, to sever from the electric grid because of the cost of that. And really the other is then you're your own utility, which then means if there's an outage, you're responsible for yourself, and not a lot of people are ready to take on that responsibility for maintaining their own electrical system. So in general, I'm going to say it's probably not economical. We can talk about that more if you want to send me an email or something. We can visit.
Great, thanks, John. And somebody who looks like is doing an install this month just had a question about if they can get NPPD to allow them to monitor. Do you have any advice?
Yeah, I think we're just thinking about that in a different way. The monitoring that you do for your solar array is on your is on your own side of the system. Your inverter, whether it's a microinverter or a string inverter, once the inverter is connected to the internet, you monitor through the inverter's website. So let's just use an example. We have a Enphase microinverters. The company Enphase will host a site that will allow you to monitor it. And typically that monitoring, at least at some basic level, is free. There are some pay versions where you can get more details, but all of the inverter manufacturers that I know of have a free version to monitor those systems online through the inverter. So you'd be doing that on your own. NPPD through your meter is going to be able to look at how much electricity you sent to them, but they're not able to look at the totals because they're getting C in this case. They're just getting B in our representation earlier. So you would do that monitoring. You'd set that up on your own. Your installer should be able to help you do that. Most installers can, but give me a call if you have any questions about that. But yeah, work through your installer to get that monitoring set up.
And then there was a comment from somebody when you were talking about, you did talk about incentives and things, but they mentioned that the Department of Environment and Energy has a low interest loan program for solar. So if somebody wants to finance, they might benefit from that. If I don't know if you're familiar with that or want to offer any comment on that.
Yeah, I'm glad it was brought up because it is that is correct. There you can finance through the Nebraska Energy Office with a low interest loan program. You work through that and send them the details, and then you end up getting a loan because the way that works, then your lender gives you a better rate. So absolutely, Department of Energy and Environment provides that. Also, there are some different kind of loan options through that USDA Rural Development Grant as well, but absolutely worth mentioning. Good, thank you for bringing that up.
And then a couple more questions about net billing. If you know specific utilities or if NPPD or OPPD does net billing, if you want to comment on that at all.
NPPD and OPPD both do net metering, and they do because they have not met the threshold to change that yet, though both NPPD and OPPD have some different policy setups for systems that don't qualify for net metering. So let's say you put in a system that's larger than 25 kW. So you're a big farm operation and you put in 100 kW solar. Well, you're going to then be on a different policy scenario because only 25 systems 25 kW and smaller. And so in that case, then NPPD and OPPD have policies other than net metering for those larger systems that are still behind the meter. But anything 25 kW and smaller, OPPD and NPPD are doing net metering.
Great. And we have a couple of questions about just the roof structure, what's needed on the roof when installing panels. What kind of a roof covering is recommended? And then if you need extra structural support typically, or if it might affect roof life.
Well, it actually would help with the roof life underneath the solar. The trouble is it's not going to help the roof life on the other side of the roof. So if you get a hail damage or something, likely you have to pull the solar off and put the solar back on, which is actually common where the roof doesn't survive the hail, but the solar does. But this said, do I need extra structural? In most cases, the answer is no. But particularly there are some roofs on maybe some garages and things where you might add a little bit of extra support to make sure. But in general, the Lincoln and Omaha have basically shown that the roof, that a well-built house, built-to-code house, can handle the solar on top because it's not a large amount of extra wind or weight loading. But in the case of we get a more of a barn building or something, then extra structure may be needed to help with that. And so sometimes we'll add extra purlins or something like that to give more structure. Good question. Typically, you don't want to put these on a building with an old roof because the worry of the extra cost of, well, when I want to replace the roof finally, I have to take that solar off, which is doable, but kind of a pain. So typically on newer roofs, They work really well on metal roofs. Those are the asphalt shingle roofs and metal roofs are the most common, but they both work reasonably well.
Great. And is there anything you'd like to say about taxes? We had a question about taxes, if those need to be factored. And I think maybe that came when you were speaking about the projected cost per watt, perhaps.
I really needed to, I really kind of skipped out on some of those details, and I thank you for bringing them up. The REAP is taxable, and so you need to take that into account. When I do modeling, I absolutely take those into account. When I do really basic calculations, I don't. But when it comes to doing a good job, good full analysis, we take into account the taxes of the REAP grant and all of that. We also account for the increased cost of electricity over time. And so what we try to do is look at the long-term increases so that we don't over or underestimate that. But I have had people that are very maybe worried about something changing, and they'll say, well, what happens if we get a really high level of electrical inflation and electricity prices skyrocket? What is it then? But so in those cases, I tend to do a range of I will do an analysis where I do more of the standard increase that's conservative, and then maybe one of kind of worst case scenario. And then we recognize that what the range of the economic return could be.
Great. We also have a question about getting electricity to irrigation systems. If you have any experience or comments on that.
Yeah, here's the thing with irrigation systems. It seems that is a really good application, and it's an okay application, but there's a couple challenges. Well, the first thing we have to think about is that without any batteries, that solar array isn't necessarily running the irrigation system directly. It is simply offsetting the energy use of that. And so I don't have to size it directly for the irrigation system. I can simply put a solar there connected to the meter that feeds the irrigation system. And then when the solar is generating, the irrigation system uses it. When it's not generating, the solar is going out on the grid. But that's where the rub is, because that irrigation system is really only running 3 months a year. And that solar array is running 12 months a year. So we have 9 months a year that solar is just putting onto the grid and getting the avoided cost or that wholesale rate for. By only those 3 months a year is it getting closer to that retail rate. So when we do an economic analysis, in most cases, irrigation systems have a lower solar on an irrigation system alone has a lower economic return than solar on a load that is more consistent, like a hog barn or some more consistent load. Yet, I want to throw in the X factor of this USDA REAP grant. You know, we throw in the USDA REAP grant into that calculation, and that those economic returns on an irrigation system can still look pretty decent. So though in general, it's not maybe the best application, the economics still may work out in the sense with this REAP grant.
Perfect. And we are at our hour here, but John, if you're okay with it, we can hang on here for a little bit and try to address some of these other questions if you have a few more minutes.
Yeah, I'll stay on for a few minutes. Okay. I'm reading the next question about a solar array added to a farm that also has a farm residence. That is a complexity in the REAP grant, in which case the way to look at that is if I have a farmstead and that farmstead, the residence is greater than 51% of the total load of that farmstead, the REAP doesn't qualify. But if the farm load is 51% or greater of the total, the REAP grant can be received, but it is reduced based on that, because essentially the residence cannot count. And so I reduce the tax credit based on how much of the percentage of that is. So rural residences, and this does happen quite a bit, where the farm and the residence are on the same meter. So there's two ways to think about that. One is you could separate and have 2 meters. That may not be cost effective to do, or we try to make sure that we've done the analysis to say, is it 51% or greater? of the load, the farm load. So good question. Part of the complexity of that REAP grant.
Perfect.
You could also separate, if you separated the meters and had 2 meters, you could put solar on each, get the REAP grant for one and not the REAP grant for the other, and get the federal tax credit on both. So there's lots of ways to think about that.
Perfect. A couple of geographical questions in the Sandhills. It seems like gravity storage would work if you know of anybody doing gravity storage in Nebraska. And then as you get farther out into western Nebraska, any advantages there because of cloudless days that you would note?
Let's start with this gravity storage. I'm trying to interpret that, and maybe if I'm not right, please correct me. Essentially, when we store electricity, there's only a couple of ways electricity is stored nationally. It is stored in very small situations in large batteries. There's at least 1 or 2 locations in Nebraska with a large battery that do at least some small amount of storage. Large scale storage is done with what we call pump storage, where they pump water up into a reservoir and then let it out through a hydroelectric system during the time they want it. That's a pump gravity storage. In that sense, it is there is none in Nebraska. There's very few in the United States. There's one in Michigan, but there's very few in the United States. So storage of electricity is essentially very uncommon, though it is kind of very much desired by the grid and by the federal government. And there is actually some now subsidies to put in different storage capacities on the electric grid. If I interpreted that wrong and it was something different, let me know. But that's what I was thinking about.
Perfect. And maybe we'll try one more here, John. And if you see one that is particularly compelling and helpful for a broad audience, we can grab that out of the chat. But
well, let's just read through them real quick. How likely is the REAP rewards to be received? I think that they are going, if you have a good application, I think that they are reasonably likely because of the increased funding. And so that a better answer might be given by the rural development folks here in Nebraska, what percentage are actually being funded. But I do feel like that we have a pretty good chance of getting funded today. Though if meeting that grant is part of you doing this project, wait till you get it or not get it before you buy anything. Don't buy anything till after you've heard word, because this is a reimbursement grant. And if you buy something before you know, it may not qualify.
And when it comes to the policies of utilities in Nebraska, is there a place, convenient place to see those current policies, what they are? And then the question asks if it reset, those tend to reset every year and at certain points.
There is not a good place to find the policies. And actually, it's quite difficult at times even to find them on the utilities websites. The best thing to do would be to call your utility and ask, and be patient, because not everybody's, you're going to have to get to the right person within that utility to answer. But that's the best thing. We can look at the state law to look at the net metering policy. That helps us at least clarify what it is. But individual utilities, it's going to be hard to find out without just calling them and asking them. You asked if it resets. Essentially, this threshold of 1%, when a utility's reached a capacity of 1% of their demand as net metered customers, they don't have to net meter anymore. But as I understand, if the utility's demand, peak demand goes up sometime in the future, that 1% will reset. And so that they may end up having to net meter some customers sometime in the future. So really, if you have a growing electric load in a particular utility, that might change over time. But I would expect that might be maybe kind of on an, I don't know if they look at that annually or quarterly or how they look at that.
And of course, with those utilities here in Nebraska being public power, there's a question if local energy retailers need to get public input on their policies for renewables.
I would say that their policies are approved by their boards And so that would be where they could get public input. I don't think there's any requirement for public input, but I think they could get public input through their boards, because that would be probably approved by their board, I think. So that's a good question. I might have to look more into that.
Great. And then a good question here about how does one account for potential growth of electrical use when you're talking about charging electrical vehicles or other expanded use when calculating load projections?
I think it's just a matter of estimating. And I think we could look at, with an electric vehicle, what I would do would be simply consider how many miles I might drive a vehicle, and I can estimate that based on my driving currently. I can make a middle of the road guess on the efficiency of those electric vehicles, which is somewhere between 2 and 4 miles per kilowatt hour. So you might just say 3. Unless you're going to a pickup, then you use 2. But 2 to 3 kilowatt hours or miles per kilowatt hour. Then you have then you have a load for the year anyway. If you drive evenly throughout the year, you divide that by your month, and you could add that in. And again, although the utility doesn't want you to put in more than 100% of your load, some of them will up that a little bit to 110, or they'll let you put in a little bit more, understanding that maybe loads will change over time, or it's just an estimate. So that'd be the way I would evaluate some increase in load, like a car.
Perfect. And then we have a couple of questions just asking kind of about specific lists of installers in Nebraska for those out in the Panhandle, even in Wyoming or neighboring states, and then asking about, again, finding specific policies for specific utilities and companies out there. So just in general, are there resources that people can look to that might list installers, or is it just
there used to be, but there's the one place that listed those installers was an advocacy organization. They actually closed their website, so it's not there anymore. But the place I would look for installers is to look at your utilities website, or another utilities website that's maybe bigger than yours if you're a muni or a small co-op. But NPPD, OPPD, and LES, the 3 large utilities in the state of Nebraska, have programs that they call Solar Trade Allies. And those trade ally programs are essentially a way that they're trying to improve the knowledge of the installers in their particular region. And so they have a list of installers that are part of that trade ally program. That doesn't guarantee that they're the best installers, but it does guarantee that they've communicated with the utility. So look at those utilities websites and look for their solar trade ally programs. Those would be a list of installers that you might start with from a region. If you have any questions about picking an installer, I'd be happy to visit with you to talk through some of what I tend to do is talk through a series of questions that you can ask them that'll help you gauge the level of experience of those particular installers.
All right, well, great questions. And do you see John's contact information there on the screen, and get a hold of him if you have any further questions, and especially check out that website, bioenergy.unl.edu. And John, I want to really thank you for a great presentation today, answering a lot of questions, and we'll be sure to get this recording posted up on our Center for Ag Profitability's website, cap.unl.edu. That link is in the chat. That should be up by tomorrow afternoon, I expect. And next Monday, we'll be back with a special webinar, our Ag Land Management Quarterly webinar, Monday at noon, with the latest info on cash rental rates in the state and how changing commodity prices could impact things in the coming year. And then check that out, register for it at cap.unl.edu again. So with that, we will wrap things up here. And John, I want to thank you again for all the great information today.
Glad to come. Thanks for inviting me.
All right. Have a great afternoon, everyone.